All right, folks, here we go. Last video. We got 3 more questions. Easy. Number 12 first. 2 over x minus 3 greater than 1 over x plus 2. And we got a issue here again. We got a greater than symbol, but there's not a 0 on one side. So easy fix. Subtract from both sides, right? Subtracting on that side, I'm going to get minus 1 over x plus 2. And now it's greater than 0. So that's what I want. And then this now is not a rational expression, but it's easily convertible to rational expression. How do I do that? Just change to common denominators, right? Here's a quick reminder. How do you add fractions or subtract fractions? Let's say I had 2/3 and I wanted to subtract 1/4. What do? Well, you look at the bottom, you say, okay, I need to find the smallest common or the least common multiple, right? And you do that, easy way to do that is just multiply by each other. So multiply this 3 by 4 and the 4 by a 3. And that might not necessarily be the smallest. In this case, it is. But at least it'll be a common denominator. And then if I do it to the bottom, I should do it to the top, right? Something like that. And then from there, multiply out, and you can subtract afterwards. I mean, we've been doing this before, but just a quick reminder. Okay, so that's what I'm going to do here. I'm going to take this guy. I'm going to multiply this by x plus 2. Right on the bottom. And if I did it to the bottom, I'm doing it to the top, because what I'm really doing here is just multiplying by 1 in a little clever way. And multiply this by x minus 3 in top and bottom. And so that way it's going to be the common denominator of x plus 2, x minus 3. Okay, next line. 2 times x plus 2 is going to be 2x plus 4. On the bottom, it's x plus 2 times x minus 3. Okay, then I have minus the other guy. This is 1 times x minus 3, which is just x minus 3 over x plus 2, x minus 3. So now they have the common denominator, right? It's all greater than 0. Same common denominator here, so I can just combine them to one single fraction. That's going to be, let's change color, 2x plus 4. Here, I recommend keeping this thing that you're subtracting in parentheses so that you don't mix up the signs here. And that's all over x plus 2, x minus 3, right? Okay, so now let's carry out the subtraction. This is 2x minus x, that's x. And then positive 4 minus negative 3 is 4 plus 3, so it's x plus 7 on the top. X plus 2, x minus 3 on the bottom. Okay, there's a 0 at x equal to negative 7. Undefined or asymptotes at x equal to negative 2 and x equal to positive 3. So easily graphable from that information. Also note that the denominator has a greater degree than the numerator. So that means I have an asymptote right at the line y equals to 0, right? So I got a horizontal asymptote right at the origin here. And then I got vertical asymptotes at negative 2 and at positive 3. 1, 2, 3. Like that, right? Okay, and then let's also check, let's just check some easy test points here. So I'm going to check where are we at 0. You know what we're going to do, guys, is we're going to do this analytically and graphically. We're going to do both. It's good practice. So what were our important points to check? First of all, negative 7, right? 1, 2, 3, 4, 5, 6, 7. That's over here, negative 7. And we had negative 2. And we have positive 3. Negative 2 is right over here. And positive 3 right there, right? So this one was the 0. These are, what do you call it? Asymptotes or undefined. Right? Okay, so let's check a point at each spot. To the left of negative 7, negative 8. Between negative 2 and negative 7, I'm looking at negative 3. Between negative 2 and 3, looking at 0. And here 4. Yeah. Okay, if I plug in negative 8, what am I looking at here? I'm looking at this expression right here, right over here, right? Just get rid of this to make it easier to look at here. So that's the expression I'm looking at, and I'm going to plug in one by one. If I plug in negative 8, this thing in the top is going to be negative, right? Negative 8 plus 2, negative. Negative 8 minus 3, negative. So all in all, this is going to be negative to the left of negative 7. Okay, then I'm going to go into my next test point, which is negative 3. Negative 3 plus 7, that will be positive on the top. Negative 3 plus 2 is negative. Negative 3 minus 3 is negative. So two negatives and a positive makes a positive overall. Okay, now on to 0. If I plug in 0, 0 plus 7 would be positive, 0 plus 2 would be positive, 0 minus 3 is negative. So overall negative, because it's an odd number of negative signs, right? Okay, and then for 4, 4 plus 7 is positive, 4 plus 2 positive, 4 minus 3 positive. So overall positive. So each time it switches signs. Now let's go to graphing. Actually, let's answer the question first, and then we'll graph. So answer, because I can answer analytically with just that information alone. I'm trying to answer when am I bigger than 0, right? So bigger than 0, I'm looking at this interval right here, not including the points themselves, and then this interval here, not including the point itself. So that would be from negative, oops, wrong pencil. From negative 7 up until negative 2, not including those points, and in union from 3 onwards. Honestly, when it's strictly inequality, makes things easy because I don't have to worry about including points or not. I just know everything's not going to be included. The endpoints are all not going to be included. Okay, now let's go to graph, see what happens. So remember we had the asymptote, but in this case, we cross the asymptote because look, we have a intersection there, right? Negative to the left and positive to the right. So that means it must look something like this. Let's do the graph in purple. So approaching that vertical asymptote this way, right? It's going upwards, and then it hits that value through the x-intercept, and then it crosses, and then after that it should level out to approach the horizontal asymptote, but never cross it again, right? So something like that. Okay, and then at 0 it's negative. Let's see, to the left of negative 2 positive. Okay, yeah. So at 0 it's negative, and it doesn't cross the axis again, so it's got to be like this, right? Approaching those asymptotes in the bottom, and then at 4 it's positive, so that should be up here, and then approaching that horizontal asymptote like that. So that's a rough sketch. And again, you see, just looking at it by inspection, you see it matches the interval that I had given over there. Okay, that's number 12. And we, along the way, doing 12, we got some practice graphing a rational function as well, which is something that for sure we're going to have to do at some point during our next exam. For sure, you're going to have to graph at least one rational expression, at least one, and then for sure you're going to have to graph a polynomial expression as well. At least one of each, maybe more. Okay, let's do the next two. Okay, 13. And these guys are kind of similar already. X minus 1 over x plus 1. And this guy's on the right. I'm going to go ahead and subtract already. This is minus x minus 2 over x plus 3. That's going to be less than or equal to 0, right? And then the same trick, I want to move this guy on the side to give myself some more space here. Same trick, I want the same common denominator. So this one I'm going to multiply by x plus 3. And if I do it in the bottom, I should do it in the top. So x plus 3 over x plus 3. This one I'm multiplying by x plus 1. That way I have the same denominator. Yeah. Okay, that's going to give me x plus 3 times x minus 1. I'm going to go ahead and actually FOIL out this multiplication here. X plus 3 times x minus 1 is x squared plus 2x minus 3. Okay, in the bottom, I'm going to leave it in its factored form because actually factored form is nice. The only reason why I multiplied this one out here is because I'm going to have to subtract it before I do my ultimate factoring at the end. Okay, this guy, I'm going to do the same thing here, multiply those guys out. X minus 2 times x plus 1 is going to be x squared minus x minus 2. And keep that in parentheses so you don't mix up your subtraction signs. X plus 3, x plus 1, right? Yeah, that's what it was. Okay, now to combine these things. And nice things happens. The x squareds cancel each other out right away, right? Because it's subtracting. And then now I've got 2x minus a negative, so really it's just a plus, which means it's 3x. And then I've got negative 3 minus a negative, so it's actually negative 3 plus 2, which is going to be minus 1. That's the top. The bottom is x plus 3, x plus 1, just like before, right? And right on. We're pretty much there already. Yeah, you know, I haven't been writing it, but I should really carry this through. This is all less than or equal to 0. That's what I'm comparing to. The numerator gives us a 0 at x equal to 1/3, because 1/3 times 3 is 1. So 1 minus 1 is 0. And then I've got asymptotes at x equal to -3 and at x equal to -1. You know, I did this in my head just now, but if you're not comfortable doing that in your head, that's okay. Just break it out on the side and then solve equal to 0, right? So you add 1 to both sides, blah, 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 blah. You'll see that you get 1/3. Okay, but that's something I expect you to be able to do, solve that equation. If you don't do it in your head, it's okay, but do it on the side if not. Okay, so here we are. Let's do this one analytically. The graph would actually look pretty similar in a sense to the previous one where you have 2 vertical asymptotes, right? And then you got 1, 0 somewhere. But I'm not going to graph the whole thing. I'm just going to go ahead and look at my important points here. Important points, first of all, are -3. And then -1. And then somewhere over here, 1/3. Now, the spacing is not accurate. I just have them in order from left to right with just any random spacing, really. I just care about the order they appear in, not how accurate I am with the spacing. Okay, so I should pick something to the left of -3. -4 is obvious choice. Between -3 and -1, -2 obvious choice. Between -1 and 1/3, 0 is an obvious choice. And then after that, 1 would be the obvious choice. Yeah, and you don't have to use those numbers, but something that's between, you know, these values, and to the right of 1/3, to the left of -3. Okay, so those are my test points. I'm going to check. And what am I checking it against? I'm checking it at this stage right here where I'm erasing this extra stuff. I'm checking it at this position right here, whether I'm positive or negative. Starting with -4. If I plug in -4, this guy for sure is going to be negative. Right? Oh, that's not a good color. Let's go ahead and use black. This guy's going to be negative. Down here, -4 plus 3, negative. -4 plus 1, negative. So I got 3 negatives, which overall gives me a negative over here. So negative to the left of -3. Okay, I didn't like that color choice. So what I'm going to do is actually erase that highlighting. Let's go back to doing purple. Okay, so that means purple here too. Okay, negative. Okay, now -2. If I plug in -2, that's -6 minus 1, that's negative. -2 plus 3 is positive. -2 plus 1 is negative. So 2 negatives and a positive make a positive overall. Okay. Positive over there. -1 and 1/3. I'm checking 0. Yeah. So I plug in 0. This is going to be negative. That's going to be positive and positive. So 1 negative overall makes negative. Okay, and the last one, I'm checking 1. 3 minus 1 is going to be positive. 1 plus 3 is positive. 1 plus 1 positive, so that's going to be positive. So it just switches at each area. You know, as I'm doing this, guys, I'm thinking, you know, this process of writing this kind of number line thing, this is actually a good idea to do anytime you have to actually graph a rational expression. I forget if I walked you through that particular method or not, but I would do this if I had to graph a rational expression, because that tells you everything where you're positive or negative. And also make a little note here. Which ones are the zeros? This is the 0 right here. Whereas these guys are asymptotes. Previously, I'd written U and D for undefined. But in this case, you can be a little more specific. These are asymptotes. Okay, so now what am I looking for? I'm looking for where my inequality is less than or equal to 0. So that should be the less than areas, right, from here. And also any points. This one is not included, though, because that's an asymptote. And then over here, in between these two regions, I should include that. This one's not included because that's an asymptote, but the 1/3 will be included. So now we're ready to write our final answer. From -infinity up until -3, that's where it's less than 0. Don't include -3 because that's an asymptote. Union from -1 up until 1/3. I do include 1/3 because that is a 0. That is a 0. But not the -1 because that one's an asymptote. So there you go. Sweet. Okay, I feel compelled to sketch this graph. I'm sorry, I don't know what's coming over me, doing extra work here, but I just feel like this is good practice for us. Let's just do it real quick. It's the easy one. So like I said, a horizontal asymptote because the degree in the top is smaller than the bottom, right? At y equal to 0. So that's a horizontal asymptote. I got one at -3, 1, 2, 3. And I got one at -1. So that's right here. Ooh, they're kind of close together. Okay. And I've got a 0 at 1/3. So somewhere over here. Okay, so what happens with the graph? To the left, it's negative. And so it should be something like this, approaching that asymptote and then going down, approaching the vertical asymptote. Approaching the horizontal asymptote to the left, approaching the vertical asymptote as it goes towards it to the right. And then between those, I'm positive. Don't cross, so that means you have some kind of shape like this, right? So the U shape approaching the two asymptotes. And then it's negative until it hits that 0. And then crosses over to being positive. Oops. Like this. And then after that, it should go back to approaching the horizontal asymptote. So something like that. That's a sketch. Alrighty. I think I actually had graphed this previously as a check. See if I have that. Yeah, see, here it is. See the general shape matches, yeah? So, yeah. Sweet. Did that match? Yes, that matches, yeah. Overall shape matches what I have here. Okay, so yeah, that's what I just done that previously to make sure that I had the graph right. Okay, so this is 14, last question. And we're out here. I'm not gonna bother graphing this one. I know I've said that before and then changed my mind, but I'm pretty sure I'm not gonna do it this time. Okay, so again, same issue. There's no 0 on this side, but easy fix. Subtract it on both sides. So I'm going to just make myself some space to do that. Subtract 6. Now that's less than or equal to 0. And here it does not look like a rational expression, but no problem. Just, make everything over x, right? So multiply this by x over x. Multiply this by x over x. So what does that give you? It gives us x squared over x plus 8 over x minus 6x over x. And now everything is over x, so you can combine it. That gives you x squared. I'm going to reorganize this a bit. Move this minus 6x over here, because then it's, it's an order of decreasing degree of the x terms, or the terms are in decreasing degree. So plus 8, yeah, plus 8. And then the bottom is just x, because they're all the same denominator. Okay, I got x squared minus 6x plus 8. That's nicely factorable. That's x minus 4, x minus 2, because negative 2 times negative 4 is 8, and negative 4 plus negative 2 is negative 6. So that's over x. And I've got zeros here at x equal to 4 and x equal to 2. Those are the zeros. Here I've got an asymptote at x equal to 0. Okay, great. Looking nice. This is a case where if I was to graph this, I'd have an oblique asymptote. And to find that oblique asymptote, I just focus in on this stage right here where I have the expanded form for my numerator. And to carry out the division, actually, this is such an easy one. It would be x minus 6 would be the line. Uh-oh, guys. I'm feeling like the urge to graph this thing. I don't know what's going over me, because this is 0. Checking these 3 important points, yeah. That one is the asymptote, just say ASY for short. And then I've got 2 here and 4 here. These guys are zeros. Yeah, that's a 0. Now I'm not gonna graph it, guys. I'm not gonna graph it. Okay, so I need to check some test points. Something to the left of 0 would be -1. Between 0 and 2 would be 1. Between 2 and 4 would be 3. And then to the right of 4 would be 5. So I got 4 test points. Okay. Where am I checking those? Oh, I'm gonna check them at this position right here. This is the spot I'm gonna check those at. Okay, so I'm gonna plug in -1 first. If I plug in -1, -1 minus 4 is negative. -1 minus 2, negative. -1 bottom, negative. Negative makes a negative overall. Okay, next I'm gonna check the +1. +1 minus 4 is negative. +1 minus 2 is negative. +1 on the bottom is positive. I started off writing a negative. That's positive, okay? Two negatives and a positive make a positive, right? Okay, on to the next one. And it, you know, a lot of times it seems to just kind of be switching, yeah? Seems like to be a pattern we see. 3 minus, but not always, not always. So you gotta still check. 3 minus 4 is negative. 3 minus 2 is positive, and then 3 over here is positive. That makes a negative overall. And then 5. 5 minus 4 is positive. 5 minus 2 is positive. 5 is positive, so that's positive overall. And then what do I want to know? Okay, I wanted to know when it's less than or equal to 0. So for sure, I'm going to have all the negative portions, this area here and that area there. And now the question is which endpoints should I include? Switch to orange to answer that question. So this one is an asymptote, right? So no matter what, that one's not going to be included. So not that guy. Now these guys are both zeros. So yes, I do get this one and I do get that one. And it coincides with this. Oops, sorry. Coincides with this guy being in inequality with the equality portion of possibility. So it has that line underneath, which means equality is a possibility. So that means when I do my answer, it's going to look like this. Negative infinity up until 0, but not including the 0. And then from 2, but this time including the 2, to 4, close it off, including the 4. So those are spots where I'm either negative or I'm 0. Okay, and there you have it, folks. That is it. We are done. So here's your final answer. Great. Okay, guys, hope you had a great day today and you have a great rest of your day. See ya next time.